In this example, we are going to find that the maximum speed of the truck when the radius r of the banked curve is 50 meters. So the coefficient of friction is 0.6 and the banking angle alpha is 20 degrees. To find the speed of the truck, we are going to use Newton's law. For this, we need the free body diagram. We need to know how many forces applied on the object. So the object is under mg. Then normal force is perpendicular to the surface. And then we have friction force is on the surface going in that direction. So the direction of the acceleration, remember the acceleration is centripetal. It will be parallel to the ground because the object will be making circles, and these circles that will be parallel to the ground. So the acceleration will be centripetal. Shrink the object. We'll have object here. We said normal force is perpendicular to the surface. mg is perpendicular to the ground. And then we said friction force is going with the surface. And then the direction of centripetal acceleration will be parallel to the ground, because this circle where the truck is going will be parallel to the ground. So this is, I suppose, my x-axis is the direction of acceleration. Y-axis is perpendicular to x-axis. And this angle we said is alpha. If this angle is alpha, this angle should be alpha because these two lines are parallel and the alternate angle are identical. And also I know normal force is perpendicular to the surface. So this is our x-axis. Let me put it back. So if this is alpha, I know this one, I call it beta. This is alpha. Beta plus alpha, remember, is 90 degrees. Beta plus alpha equal 90 degrees. And I want to know what this angle is. Gamma, I call it gamma. Now also we have x is perpendicular to y, means beta plus gamma equals 90 degrees. What that means, beta plus alpha equals beta plus gamma. So alpha is gamma. That means this angle here, this angle we call gamma, is just alpha also. Why I'm looking for these angles? Because I need to find the direction and the magnitude of these forces Fn and friction force on the x and y axis. So what do we have? For applying Newton's law, what do we have? Sigma F equals to the mass times acceleration. Coordinate on x and coordinate of the net force on y-axis. What do we have? We have normal force, the projection of normal force on x-axis. What will be Fnx? Let me put it here. Fnx will be just Fn, the hypotenuse, times sine of alpha. It will be Fn sine of alpha. For vertical axis, Fny, put it here, it will be just Fn cosine of alpha. Now I need to find friction force. We have friction force on x, it will be just friction force cosine of alpha, and friction force on y in magnitude, it will be just friction force sine of alpha. Okay, so and mg we have it just on y-axis. That means sigma f on x-axis will be just the friction force on x plus normal force on x. Friction force on x will be just friction force cosine of alpha plus normal force sine of alpha. And this equals the mass times centripetal acceleration, which is the square of the speed over radius. In vertical direction, what do we have? We have normal force, friction force, and mg. We have normal force in y direction, we call it Fny. We said Fny is just Fn cosine alpha. It will be Fn cosine of alpha minus friction force sine of alpha, because friction force is on y-axis. This friction force will have this coordinate. We got friction force on y. Remember, is downward. This is where we put negative. And also mg is downward. It will be minus mg. The sum of forces on vertical direction equals 0 because the car or the truck is on the embanked curve. It is making just circular motion on banked curve. That means it doesn't fly in vertical direction. So the sum of forces on y-axis equals to 0. By definition, the friction force is the coefficient of friction times normal force. We put this equation down here. We have normal force cosine of alpha minus friction force, which is the coefficient of friction times normal force, times sine of alpha equals to, if I move negative mg to the other side, with just mg. So what will be normal force? If I put outside normal force, it will be times cosine of alpha minus mu sine of alpha. This is equals to mg. So normal force here, it will be, let me clean this now. The normal force, it will be mg over cosine of alpha minus mu sine of alpha. From the first equation, we have friction force times cosine alpha plus normal force sine alpha equals to mv squared over r. We know friction force, we said friction force is the coefficient of friction times normal force. Okay, so I can replace this with normal force, and I bring this, what will be coefficient of friction times normal force cosine of alpha plus Fn sine of alpha equals mv squared over r. Now I can put outside normal force. It will be normal force factor of mu cosine of alpha plus sine of alpha, close parenthesis, equals mv squared over r. Now I replace this term, normal force, with mg over cosine of alpha minus mu sine of alpha. What do we have? We have mg over cosine of alpha minus mu sine of alpha times mu cosine of alpha plus sine of alpha. Okay, I just put this term here. And this is equals mv squared over r. Okay, so we have mass here. We can cancel the mass, and I can move r upstairs here. So we have g times r factor of mu cosine alpha plus sine of alpha divided by cosine of alpha minus mu sine of alpha. And this equals to v squared. Now if I want a v, it's just the square root of this term. Remember, we are looking for speed. It will be just the magnitude the maximum speed at the radius r 50 meter, it will be 9.8 meters per second squared, factor times 50 times 50 meter, factor of 0.6 times cosine of alpha, which is 20 degrees, plus sine of 20 degrees, divided by cosine of 20 degrees minus 0.6 sine of 20 degrees. The maximum speed is 24.6 meters per second. Thank you.